Okay, today's lesson we are resuming section 6.1. So far we've completed determining the 6 trig ratios from an angle. We looked at determining all trig ratios given the coordinates of a point on the terminal arm. Today we'll be looking at determining all trigonometric ratios and angle measures given one trigonometric ratio. So this is our goal for today, is to determine all trig ratios. Okay, just to review, just remember your basic trig ratios. We'll be using these today. Remember, for any angle theta in the standard position, the terminal position P, X, Y on the circle radius R, cosine theta is X over R, secant theta, which is reciprocal of cos, is R over X, sine is Y over R. So your R is your radius. So cosecant is R over Y, tan is Y over X, and cotan is X over Y. So remember, this is your circle, your radius, your Y and X and Y, your values. So P of X of Y. So we'll be referring to this whenever we are solving the questions today. So I'm looking at example 4. Here's your example here. It's a full question. Determining all trig ratios and angle measures given one trig ratio. Now suppose, here we given a question, cosecant theta is equal to 3. Determine the exact values of the other trig ratios for theta between 0 and 180 degrees. Not a full circle, we're just looking at theta to 180 degrees. Now, essentially we need to find the R value. Now, let's look at this here. When we have cosecant theta is 3, now it's understood there's a 1 here. Now, if you go back to our cosecant, which is the reciprocal of sine, R over Y. So the R would be 3, and the Y would be 1. So we need to find the X. So essentially we find the X. So I started off and I did a sketch here. Oh, zoom up a little bit here. Now let P, X, Y on the circle, radius R, be the terminal point of an angle theta in standard position. So if we let that, it's basically a sketch of what it will look like. We have our standard position. Also remember your CAST rule, C-A-S-T. Cosine is positive here. All the trig ratios are positive in the first quadrant. Only sine is positive here, and tangent is positive in the third quadrant. And cos and the reciprocal of cosecant. So cos and secant are positive here and here. So here we have cosecant and it's positive. Okay. So now, but it's restricted between 0 and 180. So now we will not consider this from 180 to 360 because they restrict us, right? The domain, so they restrict us between 0 degrees and 180 degrees. So we only will consider quadrants 1 and 2. Now, since cosecant is positive, we'll only consider quadrant 1 in this case here. So here is our we give cosecant 3 over 1, which is cosecant we know from our trig ratio is R over Y. Okay. Now I go ahead and create the sketch here. This is my R, this is my Y, this is your X. We given R is 3 from here. So we can say that's 3 here. So we place 3. So we get our Y is 1, just 3 over 1. So Y is 1. We need to find for X. Okay. So we have r equal 1, y equal, sorry, r equal 3, y equal 1, x we don't know, right? So use the unit circle, x squared plus y squared equals r squared. Then we substitute r3 for r and 1 for y. So we substitute, so we have x equals, we don't know, plus y, which is 1, and r is 3 squared. So we have x squared is equal to, now we take the 1 on the right side, become 9 minus 1. So this would give us x is equal to the square root of 8 plus or minus. Okay. Now, since cosecant is positive, right, and sorry, cosecant is reciprocal of sine, and sine is positive here and here, so we have to consider these two quadrants. So we can say here, since cosecant theta here is positive in quadrant 1 and quadrant 2, right? See, the terminal arm now will be in both of these here. Are in both quadrants. Which is quadrant 1 and quadrant 2. Because we're restricted to 180 degrees, and since cosecant is positive in quadrant 1 and quadrant 2, so quadrant 1 and quadrant 2, the terminal arms are in both quadrants. So the terminal arm here, so that would be negative x here, y. So now we go back to our, we already given cosecant, we need to find the 5 other trig ratios. Using now the x now, so we can conclude now. We have r equals 3, y equal 1, then x will be equal to plus or minus square root of 8. So let's work these through now. So sine theta, if you remember, our sine theta is y over r. So y over r, which is equal to 1 over 3. Next, we go to cos, right? So we can go to cos and secant. So cos theta is x over r, which gives us x, we found is the square root. So we have square root of 8, so plus or minus. Because in this case, x is negative in quadrant 2, because cos is negative here, and it's positive on quadrant 1. So this point here would be negative root 8, okay, and the y would be 1. So this point here, if you can write it in here, oops, is negative root 8, y is 1. And over here is positive root 8, y is 1. because that's our x and y values. Now we go on to the reciprocal of cos, right, would be secant theta, which is going to be r over x. Which works out to be what? R is 3 plus or minus the root of x will be plus or minus. Let me just rewrite this a bit. Give myself some space here. Plus or minus 3. Oh, I forgot to put my r here. For root 8. So it's the reciprocal of cos. So here's my sine theta, cos theta, secant theta. So we got 3. So we need 2 more. We need a tangent. So we have tan theta. Now tan theta, we know it's equal to y over x. Or y is 1. And our x now going to be root 8 plus or minus. Right. Notice tangent is negative in quadrant 2, because you're looking at a positive divided by a negative here. Okay, so let's so y over x. So I'm just using my values here. Notice it's 3 values I'm using repeat, and cotangent theta, which is x over y. So it's the reverse over 1 plus or minus. So it's important for you to recall the 6 trig ratios in this form, because it helps you in your calculation. Now, you can do without these, but you have to remember your radius of the circle referred to the r. Your x coordinate is the x value is given. So you're using your trig functions to determine all the trig ratios. Okay. And the one is given is cosecant. The 6th one is given to you, so cosecant 3 over 1. So you're given 1, and you need to find the other 5. So you're finding 5 trig ratios. Okay, the next part of the question, part B, says, to the nearest degree, determine the possible values of theta in a domain between 360, negative 360, and 360. So if we go back to this question, so sine theta, if you look at it, is 1 over 3 back here. So let's put a line here. I'm doing part B. Okay. So since sine theta is equal to 1 over 3, because it's, you can use this as sine theta, we are going to find the angle here. Now, this angle is too steep from what we'll find, but this is my sketch. My sketch I had initially here. It's a very steep angle, but I was just guessing here. Okay, I just want to find a guesstimate, but when we do the actual calculation, it will be probably way off. So we're going to use, and it doesn't matter which one of these you use. You can use the negative or the positive, but it's easier to start off with a positive, the one that's in a positive quadrant. So we can say, since theta is equal to 1/3, so I'm using this value here. Now, you could have used any other values here. It's a little bit much easier when you're using a known value in quadrant 1, because then you can use that as your reference angle. So in quadrant 1, so theta, we need to find the angle. So we need to find the angle. So theta, right, is equal to the negative, right? Negative 1 over 1/3. Now we need a calculator for that. So we'll have to go to our calculator here. So I'm going to clear my button here. So make sure I'm in the working degree mode. So now I'm going to have in sine, so second sine 1 divided by 3, 19.47 degrees. So approximately 19.5. So that will give us 19, so which is approximately, we'll use a round figure here, 19 degrees. So if we were to look at the sketch of that, so this is our 19 degrees here. Oops, that's a little way too big. We should be smaller. Here's my x-axis, y. So 19 degrees somewhere here. So the reference angle here would be, you need to find this 19 degrees here. And so they ask us to find those angles, right? So this is 19 degrees. The other one here, so from here to here, this would be 180 minus 19. And let's give us 180 minus 19. 161. So this is 161 degrees here. Okay. Remember, because these are all positive, right? So we need to deal with only these two quadrants here. Now we have to go to the reverse now. So the reverse in negative would be from here to here. So this is 180 plus 19 degrees. So 180 plus 19, so 180 degrees plus 19 is equal to 199. So negative 199 degrees. That's one. Then we have to go to the other one, which is way over here. I'll use a different marker, use a different color. So we're going to go from here, go all the way around, over there. Now, I'll erase this here. So if we go all around, so we have, here's 180, 90. So it's 360 minus 19. So we can have here 360, right, plus 19. This will give us an angle of negative 341 degrees. So we have a coterminal angle. So we have a coterminal at 3/4 degrees and coterminal at -199. So we can conclude, right, the possible theta or angle are, because we use an approximation here, right, are approximately 19 degrees, 161 degrees. We got that here. We have -341 degrees. And the last one, no, 199, -199 degrees. So these are your possible angle. And that's what the question asks you, the nearest degree determine the possible values of theta. So your values of theta are 19 degrees. So this should have been way down here. Okay, sketch is way off. Right, so it's been here over here. Now I'll go on to a second question, check your understanding. A similar question, but in this case, we're looking at secant. Very similar process. Okay. Now, secant, just recall, is the reciprocal of cos, right? Which is r/x. Okay, so we'll put this as 1, which is r/x. Okay. So if you'll do a sketch here. Now, remember the secant in standard position is, remember, our cast rule again, and they're going from 0 to 180 degrees. So we restricted, right, between these two. And remember that secant is positive in quadrant 4, and also secant is called secant here, and in quadrant 1. But since we're restricted to 180 degrees, we will not consider quadrant 4, but just quadrant 1. So somewhere in this quadrant here, and I'll do a limb here, you have your P and your X and Y. R is 4, your X is 1. Now, I think this might be a bit higher here. So I'm just doing an estimate here. So it might be up like that. The angle should be much larger. So this is 1 here. It's going to give us R, which is 4. We need to find Y. So we'll go ahead. So we have, so if you were to write out this question here, step 1, that P xy on a circle, which you have here, with radius r, because remember r/x, be the terminal point. Angle theta in standard position. Okay, so we remember we have this secant, so secant theta is equal to 4r, which we know r over x, right? We know that r over x. So r over x, which is 4 over 1. So r is equal to 4, x is equal to 1. We need to find y. Okay. So next step, we're going to use x squared plus y squared equal r squared. I'm going to substitute the value for r into the equation and substitute the value for x here, and now we're going to find y. All right, so we're going to substitute this. So we have x is 1 squared plus, we don't know what y is, and we also know what r is 4. So this will give me, oops, 1 plus y squared is equal to 16. So y is equal to 16 minus 1 plus or minus the square root of 16. Oops, 15. Which will give us plus or minus the square root of 15. Now we have plus or minus, right? So here, I'm going to highlight that. So this is my y. So we have our x and r. Now we can find, we know our y. Now, we have to be careful, but if you go back to our circle here, our terminal point is in quadrant 1. So therefore, x and y can only be positive. So we will only use where y is positive. So let's state that here, right? So we can say since secant theta is positive, right? The terminal arm of theta lies in quadrant 1. And we discover that when initially when we were given a restriction between 0 and 180 degrees, and we know there can only be positive in these two quadrants, and quadrant 4 is beyond 180 degrees, so we are restricted to quadrant 1. But this just confirmed it, right? Just going to be in quadrant 1, where y is positive, right? So you can only use, so y is equal to plus square root of 15. So we can put that here, square root of 15. That's y. Now we can go ahead and use our other 5 trig ratios, and we can start off with cos because the reciprocal of secant is cos, so we can just go up with cos. So we have cos theta. Now we know secant theta is r over x, so we just, the reciprocal of that is 1 over 4, which is r over, oh, sorry, this is going to be cosecant to be x over r. X over r, which gives me 1 over 4. So cos theta is 1 over 4. So we already know secant, get us given. Secant theta is given. Next, we can go ahead and go for sine theta. where sine theta is y over r, or y is root 15, r is 4, then the reciprocal of sine is cosecant, which is r over y, so we have 4 over root 15. So we got sine theta. Cool. Get my symbol here. Now the last two would be tan theta, which we remember we know it's y over x, which is y is root 15 and x is 1. So root 15 over 1. Remember, these are positive because they're only in quadrant. They're all in quadrant 1. So in quadrant 1, so there's no negative. And cotan theta is x over y, which is 1 over root 15. So there are your other 5 trig values of the trig ratios. Now, the second part of the question, to the nearest degree, determine the possible values of theta in domain negative 360, between negative 360 and positive 360. Now, each one we can use is look at cos because it's an easier value to whole numbers. So cos theta, right, is 1/4. So we know it's in quadrant 1. Right, so we have here. So we have part B here. So cos theta is 1 over 4 in quadrant 1. Okay. So we do have there, so cos theta, right, is equal to sine or cosine, we do the cos here. And what will that give us? So go to my calculator and I am going to find, so we need second cos 1 divided by 4, around 76 degrees. We approximately, right? Round up 76 degrees. So now, if I were to go ahead and do a little bit of sketching here, so now this is 76 degrees. Okay. But remember, it's positive quadrant 1 and in quadrant 4. So this would be, so those are my 2 reference angles. So the first part, so we know this is 76 degrees. The next would be from all the way from here. This would be 360 minus 76. And if you work that out, let me get so we have 360 minus 76, 284. So we have 284 degrees. So we have 76 degrees, 284 degrees. That's going in the positive. Now, if you go to negative now, it will be negative 76 degrees. So we have positive 76 degrees, positive 284, and negative 76. So you have plus or minus. So your angles are, so the angles between 360, negative 360 degrees and 0 degrees are coterminal with, what do we have, 76 degrees. So we have them all here. So we have 284 degrees, 76 degrees. Now we have plus, we also have another one going around here, negative 284. So negative 284 degrees and negative 76 degrees. So possible values of theta, you can write that here, possible values of theta are, and by the way, these are all approximately because I approximated at the beginning here, are approximately plus or minus 76 degrees. And plus or minus 284 degrees. So those are our 4 goals for section 6.1. Actually, the first one we completed earlier. So today we looked at determining all trig ratios and angular measures given one trig ratio. And how do you see it? Your assignment is to work on questions 10 and 11 on page 473.